I'm Tim Kleinloog. I'm Technical Director of Deeploy. And last years I've been working as a machine learning engineer and consultant. And worked for several companies, larger companies and also smaller scale-up companies. And actually, I experienced that it is very important to when going to a production phase with machine learning, that those machine learning models should be that there should be a certain interaction with those machine learning models from a human side. So those models aren't self-explanatory, so there should be some way to control them, make them manageable, accountable, and explainable at the end. And that's actually why I started Deeploy together with 3 co-founders. And tonight I will spend some time talking to you guys about why building machine learning engines is actually a hard problem. So maybe many of you have tried to experiment with some way of building machine learning, experimenting with machine learning, but actually building a production-ready system is pretty hard. Then the need for explainability. So explainability is a whole research topic on its own, and I believe at least that it's really important for the reason that I just told you, that machine learning includes some form of explainability. Also, it has a relation to building machine learning engines. So it's not only an engineer who's going to build a machine learning engine. There are a lot of stakeholders involved. That adds a lot of complexity. Explainability is one of the solutions there. And maybe most important for you guys is just a hands-on example that you can try at home after the talk or during the talk, depending on how fast you are. Showing you the whole end-to-end life cycle using KFServing. So KFServing is an open source project. I think it's backed by Google, and with Deeploy we follow the logic that KFServing is laying out. So actually really interesting concepts there that I will show you from the end to end. So a lot of things to do in a short time. So let's get through it. First topic. So why productionizing machine learning is actually a hard problem. I actually saw 2 things. Or at least I divided them into different areas. The first one is actually that machine learning systems are technically really complex systems to deploy and maintain. I recently talked to an architect who even questioned whether a machine learning deployment could be seen as a stable software on its own. So actually a really interesting thing to think about. And then on the other hand, there is the whole process that is currently still being actively discussed in research as well as in practice. But I will give you some insights in how I think that a good machine learning process should look like, who are the main stakeholders, and why there's a need for MLOps software. So first, the first topic. So this picture may be in some form be familiar to you. So it's actually from based on a well-known paper that Google published, and actually the ML code that's also often being developed by non-software engineers is just a really small portion of the whole system. So there's a really large part of, also related to the previous talk, the whole data collection, validation, and verification process. There's a large serving infrastructure. There is a need for monitoring. There's a whole configuration and version control. It's also the technical depth here is really a point of interest. To solve this is not an easy task. And even if we think about the next step, so this paper is already from a few years ago. If we're going to control machine learning, then maybe it's getting even more complex. So all the tools and things that are being developed in order to control the machine learning code is extensive. So it's actually quite complex to make your own solution in this whole space. And then second thing is the whole MLOps process. So a slide with a lot of information. So maybe you've seen like the phases in the loop before. So in DevOps provides some practices, of course, for machine learning that we can use. So of course, many of you are familiar with the infinity loop. But with machine learning, often there is a phase added before that, and that's actually the exploration phase, where also after the exploration phase, many good initiatives die in the laptop's graveyard, so it's never going to arrive at a development or operations phase. And also the stakeholders, so maybe some of you are even involved in those processes. There is, of course, in machine learning, if it's not like a business problem that we're trying to solve, that's quite a rare case. So normally there's always a case where we can add value by applying machine learning. Of course, we want to try to let the data scientist be as autonomous in the whole process as possible. So there is the most statistical knowledge about the modeling procedures, which algorithms to use, the cooperation with the business again to define evaluation metrics. But also related to the previous talk, there's not only like the business and the data scientists who are like celebrating their freedom in modeling and solving problems. There's also like a whole legal and ethical framework where we are behaving. It's actually the whole ethical and privacy framework is a bit behind the whole machine learning movement. So it's actually good to incorporate that in your whole MLOps process, because eventually it's going to be there and you have to answer to the questions that are being asked. So actually, to do the first part right, there are a lot of tools being developed. So there's just a unified way of data and modeling and experimenting, comparing your runs, a whole lot of space. So actually, in this talk, I'm mostly interested in going to demo the second part. So that's more the unified way of deploying your models to a production state. And there's also the integration part with your business application that's going to consume the results of the machine learning. And there's also really a need to control an algorithm when it's actually producing results in a production setting. So for that, explainability is one of the solutions. So let's dive a bit more into that. So the need for explainability. So as you've seen, the many stakeholders, they are not all statistical experts or really technical people. So understanding what a machine learning system is doing is of keen importance for the success of the system. So it can be technically perfect, the model can be a genius, but eventually it's only going to be successful if like the involvement of the different people are there. So from a business point of view, there needs to be, at least I believe, there needs to be some involvement in the automated decision making. So if it's not validated by an expert, there's no trust in the system. It's doomed to fail. Then there's the data scientist who can also use explainability for mostly sanity checks. That's actually, I think, currently the way it's used. So there are already, of course, data scientists using this, especially for just sanity checking their outcomes. Especially with really complicated machine learning models, you can always use explainability sanity check this. And eventually, this is still, of course, something that's a next step again is to involve like compliancy to check the fairness of this decision. So really making sure the decisions are fair is still quite hard, and that's mainly because of the reason that you see on the slide as well. Explainability is again a statistical method, so it's not going to underpin any causality. And if you're speaking about explanations, it's actually easy to make that mistake. That this is still like a sort of using algorithms to validate algorithms. So that's also one of the main reasons why this is in practice. It's still quite hesitant to use these methods, but it's certainly potential. So how to approach this then? What I would say, thoughtful deployment. So if you're going to deploy machine learning, there are a lot of possibilities there, and there are also a lot of nice algorithms and libraries being developed. So why not just use it? But make sure to keep into account the following things that I list down here. So, of course, the context is really, really important. So, make sure to evaluate on the right metrics, understand the limitations. So, different algorithms that are being used. In the demo that I will show you, I'm going to use anchors. So all of these algorithms have their pros and cons, so make sure you know the limitations. Also know how to deal with uncertainty. So as well, machine learning and explainers are going to fail. There's always an uncertainty, so that uncertainty can be really low, but it's not going to underpin any causality. Yeah, also understand the interactions from the people that are going to use those explanations, and make sure to understand the expected change in behavior. So below I made a drawing of how such a process could look and who are the stakeholders involved. So actually the picture that you see and the small images are based on a real life case that they actually participated in. So it's for handling airline claims. So according to some laws in Europe, you are able to get your money back if your flight is delayed. So what's being done is on the website, they're customers filling out a form. The company is collecting the data, and there are a lot of actually legal experts assessing all those claims, which you can imagine. In Corona time, this is a little bit less, but before in the summer times, they needed to scale their legal experts, and that's actually quite hard to do. So in order to do that, we applied machine learning there. And but in order to build the trust of those experts, we used explainability to involve them in the whole process. Not by telling them what to do, but actually involving them in the process, so giving them an advice on whether a claim should be eligible for a refund, and actually collecting their feedback, building a whole feedback loop to again improve the whole system again. So that's actually one way to apply explainability in practice. But of course, we didn't involve them immediately because that would change their behavior. We first did some shadow runs in order to make sure that the model is again good enough to involve people there. Yeah. Then I'm going to move to the demo. So a lot to explain here as well. So this is actually the standard that I'm going to show you today and to demo with you, and also give you the ability to try this yourself. So actually there's a link in the slides as well to a GitHub repo where you can reproduce what I'm going to show you today. So actually we're going to start from a situation where we have already trained a model, and we're going to upload that to an S3 storage, so that can be on Google, on Amazon, or on Azure, whatever you like. We're going to use our local machine as our compute, so I'm going to use Kind for that. That's actually a local Kubernetes cluster. And on top of that Kubernetes cluster, I'm actually installing Istio as a service mesh and Knative for using its serverless capabilities. It's especially useful when you're going to run really big models with large GPUs that you want to save some costs. And KFServing is actually a custom resource definition on top of Knative that's able to, based with a certain abstraction level, use actually the most well-known machine learning frameworks that are there. So as a machine learning model, I'm going to use a scikit-learn model. Maybe you've used that yourselves as well. And actually there's also there's also a first explainability library, Alibi, and I'm going to use Alibi to deploy the anchor explainer. And together I'm going to make the explainable machine learning deployment. So eventually we're able to consume predictions and explainers as well. So pretty exciting stuff. All right. Yeah, so this is the repo that you will be able to reproduce it. For now, I'm going to, I already did some preparations. So I already configured a Kubernetes cluster. I'm using Lens actually to monitor what's going on here. So there are also in the README, there are instructions to install this on your local computer. So as you can see, I installed Istio here on this service mesh. I also installed all the dependencies that are needed there. And I also made a new namespace that I called Explainable Machine Learning Engine Demo, which is currently empty. So this is actually the namespace where I'm going to deploy my explainable machine learning engine. Yeah, so that's what I already prepared. Otherwise, we're going to have a really long demo. Often making your first machine learning deployments also starts with thinking out some kind of infrastructure where you're going to deploy it. In this case, it's quite so make sure in the instructions is of course for demo purpose. So if you really want to configure this for your production environment, it's going to take a lot more effort to configure this right. But for now, also KFServing has a nice way, a nice hack as they call it in their folder to do a quick install of KFServing on your local cluster. And that actually gives the same result as I'm going to use today. So again, I already created my namespace, which I'm going to use for my deployments. And I'm using Python as my modeling language here, so make sure to use the environment that I provided here using the requirements.txt. And then, okay, the modeling can start. So I'm not going to go into too much detail here. So it's quite a straightforward ML 101. So maybe to give some context about the case here. So this is a well-known census data set where we're going to predict whether someone is going to earn over $50,000. So that's actually what we're training our model for. And that's already quite an interesting case because in this data set are quite some interesting variables that are, yeah, we could have some debate about whether it's ethical to use those variables to predict the outcome. Especially you can imagine if those variables are going to be used to determine whether you're going to have a mortgage or not. So interesting case to apply explainability. So this actually I already did for you guys. So yeah, I'm not going to explain too much. So I'm splitting my data set and doing some preparation. I'm training a random forest model. That's actually quite a black box model. So it's not really explainable anymore by itself. This is maybe a new step for some of you guys. So based on the training set that I train my model on, I also can fit an explainer. So in this case, I'm going to fit the anchor explainer that I just said is part of an alibi. That's one of the first explainability packages that is provided there. And that's going to give me the possibility to do some post hoc explanation. So based on the results that I receive, it's going to look for spaces in the data where there's a unique set of variables that's going to explain the result that I'm producing based on the input data that I'm feeding it. So actually quite interesting. So it has nothing to do with the machine learning model that I'm using for the prediction. It's really doing a post hoc explanation in order to validate it, and also can provide me with some metrics in order to assess whether I'm making some assumptions that I can or cannot do. So Anchor is just one of the many algorithms that are being there. They're actively, I think there are many papers appearing every month, so it's a really hot topic as mentioned already. So after fitting the explainer, this is the end of actually the exploration phase. So the only thing that I'm going to need to do is to export my model files in order to save those artifacts to, in this case, I'm going to use the Google Cloud storage for that. So for sklearn, we are using a joblib extension, and for the explainer, we're using a Del extension. That's actually an exporting format that can include like Python objects. And as a next step, I'm going to export it to my Google Cloud storage. So I actually already did that for you guys. So you can actually see that I have my Deeploy storage, and here's my model. Actually did that today. So this is my joblib model, and actually my explainer is here as well. Yep. So in KFServing, I can again point to those artifacts in my artifact storage, as you've seen here. So actually in the artifact storage, where I'm going to which I'm going to use to deploy my machine learning engine. So that about the training part is really fast, but if you have any, so make sure to do this in a real life setting to spend some more time on the modeling process and do it thoughtfully. This can be a really long process. Then maybe most interesting part is the deployment to KFServing. So now I'm actually in the next step of the experimentation phase. This is something that I'm going to deploy. So KFServing is a nice Python client. It's still in an alpha stage as well, so we're pretty early with it as well, but it's actually working quite well. So first of all, I'm going to load my Kubernetes client in order to talk with my local Kubernetes cluster. And then I'm going to use the KFServing client that I installed with my requirements, the TXT. And KFServing has a lot of classes which I'm going to need in order to deploy my model. So I'm going to load those in as well. And then I'm going to define some constants. So the API version that I'm using, the namespace that I'm going to deploy my machine learning engine in. There's a link to my Google Cloud storage. And because I use the credentials to make sure that not everyone can clone my explainer and my model, I also can provide my my service account here. So let's load that in. And then there's this step where I'm going to attach the credentials that I created to my namespace. So also prepared that already. So if you're going to look in Lens on the secret side, then I see that on the namespace Explainable ML engine, there's already the secrets. So if everything's going well, then I should be able to communicate with Google Cloud Storage from my local deployment, starting with the initialization of my KFServing client. And after that, I'm going to define what I actually am going to deploy. So KFServing is using a default endpoint spec for that. So the default endpoint spec is actually the default model that I'm going to explain. So KFServing also has the ability to deploy a canary endpoint as well, in order if you want to, for example, safely switch to another version of your model. And in the endpoint spec, I'm going to note to provide like the service account name. I'm also going to so since KFServing is like an abstraction layer on top of many of the frameworks, I need to point to the SK Learning spec that they are providing. Again, point to the URL. I can specify a version that I'm using. And this is also interesting. So based on the type of model that you're using, you can also specify the number of resources that you're needing. And if you want to go full serverless, you can also scale down to a minimum number of replicas of 0. So in that case, if you're not going to use you're not going to call it actively, it's going to scale down to 0 pods, and you're not going to use any resources. Then actually for the explainer, I'm going to do the same. So again, if you look at the picture, the single deployment also contains an explainer. And for the explainer, I'm going to use the artifact of the alibi explainer spec. I'm going to point to the storage URI, specify the tabular. I'm going to reserve somewhat more resources for it, because explainer still needs somewhat more resources than the standard models. And if I'm going to do that, then this can be input for my inference service object. Again, in this space, I can add some metadata. So I'm going to call it the income model, deploy it to the namespace, and here I add the information I just made in the default endpoint spec. I can immediately also add a canary deployment here. I'm not going to do that right now. And also assign a certain percentage of the traffic to the canary deployment. It's interesting to do, especially if you want to go to a new version of your model in quite a safe way. So again, I'm going to initiate that. So actually, the only thing I have to do is to to call the create method, and I get some feedback back from here. But most interestingly is if I go to the pods, you actually see that my explainer and my predictor are starting up, and this is like the live deployment of our machine learning model in our explainer. So I can also call, it's actually not ready yet, so I'm calling the inference services, and actually now still not, and now I think we should be ready. Yes, so it's actually ready. So as you can see, there is an internal endpoint connected to our deployment, so it's ready. It's going to receive 100% of the traffic because we didn't supply canary deployment. And what this means is that we actually can test it out, so that's cool. So I can also do that in Python again. So for the model, I use the income model, and use this namespace. I use the host, which is actually a combination of a namespace and the model name. And I'm using the ingress host by port forwarding it. So actually the only thing I have to do to test this out locally is to port forward the ingress gateway that also Istio is providing. So that's happening right now. Specifying our inference service. So as you saw in the picture here as well, we have an predict and an explain endpoint that's actually using the same API endpoint. And to make this more real, I also added an API that's going to provide us with some sample data. That's actually the same data set that I used to train the model on. So it's actually a really simple, fast API to provide us with some data. And now I can like call random people that we're going to make prediction for. So in this case, I have a person with the age of 53, an unknown working class. It's a white female, and yeah, somewhat more information. And actually, in order to send it to my model, I'm going to transform it to actually an API specification for machine learning that TensorFlow developed, which we're using, and making a request. And I do this on the explanation endpoint, so that's also good. So I'm getting back quite a long JSON file with a lot of information. And to make it more concrete, I filtered that a bit. So actually we're getting a negative prediction. So that means that in this case, the income is not going to be above 50,000 euros of dollars. And the explanation for this that the anchor provided is that the reason that it's thinking it's negative is actually that this person is separated and that there is an unknown working class. And it's actually pretty sure about this because the precision is above 95%. And this is actually telling us a bit about the coverage in the data set that it's using it for. So it gives us some feeling about the certainty of the explainer. So that's actually our real end-to-end deployment. So it's running in prediction on a Kubernetes cluster in a serverless way, providing us with explanations. I can repeat it once more time, so for a different person, to give you somewhat more feeling. So this is actually a person 26, never married, and made some capital gains. And again, requesting the model, giving us again a negative prediction, making the prediction based on the married and the age. So it gives you some feeling about why this is actually happening. And this can be used with business experts again to validate whether your model is actually properly functioning. So yeah, pretty cool. So I would certainly encourage you to do this, try this yourself. Yeah, thanks for your attention. So feel free to email me for any questions that you have. If you're interested in Deeploy, so maybe I showed you also that deploying those kind of models is quite tricky as well. So of course, you feel free to contact us for a demo how we are solving this problem of making explainable machine learning engines, and also if you like to work with us to accelerate the whole process of deploying, then yeah, feel free to contact me again. So yeah, thanks for your attention.
Okay, thank you very much. Loud applause here in the studio for you. So, well, I must say, watching this talk, I'm not only impressed with what Deeploy can do, I'm also very much impressed with your personal engineering skills. I mean, you're using a bunch of technologies, cloud, Kubernetes, the infrastructure, well, Python, of course, machine learning stuff, etc., etc. It's so much. So really awesome to see how you tied it all together to make it all work. I guess you explained quite well. We do have a question in the chat just coming in, and that's from Robin, I guess, judging by his last name. It's not correct, he's nodding no, and that's not the previous speaker, but it's from Triso. He's asking, awesome to learn what you're building. How would I offer my customers this explainability? Is that something you envision? I can imagine wrapping it in my own API.
Yeah, so providing it to your customers is actually what I see as really an end state. So of course, you can expose it, also maybe related to the GDPR discussion there. There is also, in the GDPR, there's a right for an explanation of automated decision making. So, of course, if you're going to use automated ways to assess and make certain automated predictions for customers, then of course, if you get a question and you're using these kind of technologies, you're always able to provide an explanation in normal human language. But yeah, I think maybe at this point in time, explainability, I'm doubting if it's yeah, you should really think how to apply it, in what use case, in what context, because you really have to make sure that your customers understand that the explanations are not causal. So that's, I think, the main reason why there's a little hesitation to use this for customers.
So one follow-up question then, because one of the issues with machine learning is that there can be a bias in your data set.
Yeah.
And I think you can help expose that bias, right?
Yeah.
And can you also get some information about how to solve this bias issue with your explanation? Can you talk a little bit about that?
Yeah. So first of all, this is bias in your data. So you can of course do some sanity checking with explainability methods that I just showed you. So in this case, in the cases that I showed you, there wasn't any like doubtful variables that are going to be returned. So if there was like sex and race was going to be returned to me, I know that I should pay attention to why the model is using these kind of variables. So and maybe that's more related to fairness, but you also have to take into account that your explainer can be biased as well. So it's quite interesting. So I would encourage you not to use explainability for troubleshooting.
Okay.
So, but you can use it finally to check predictions that are being made. But troubleshooting is quite tricky. So I think
quite tricky. Okay.
for that case, it's better to so explainability can also has a clear link also to, for example, drift. So of course the world around you is changing, and if you a model is really a snapshot of a certain point in time, and actually drift is maybe a different topic, but it's closely related, where you can of course compare the distributions. It's more of a statistical problem, the distributions of the set of the real world data that's flowing in, maybe using your streaming data, and then compare that to the data sets that you've trained. So in that case, you can detect drift, for example, using statistical tests in order to say something about whether or not you're making predictions that are based on a situation in the past. Yeah.
Got it. Thank you very much for your